40% of the web relies on an engine built in 2003, and WordPress powers millions of sites using dynamic architecture. It was an architecture designed to process data on demand, one request at a time, before the modern web existed. Introducing Nimbika, a platform built for a faster web. Every time someone clicks a link on a standard WordPress site, a chain reaction occurs, waking the server and running PHP scripts. It then queries the database and assembles HTML, causing a structural delay of up to 2,000 milliseconds. This inherent mechanical lag makes traditional WordPress architecture incapable of meeting the sub-second speed requirements of the modern web. To solve this latency problem, the web development community split into two isolated factions. The WordPress ecosystem chose to rely on caching plugins, prioritizing convenience and ease of use. The broader developer community took a different path, abandoning dynamic rendering entirely in favor of pre-building sites as static files. This split left a knowledge vacuum, leaving many unaware that a faster architectural alternative exists outside of their plugin library. Caching works by saving a temporary pre-assembled copy of a page. It acts as a shield, bouncing requests back to the user without forcing the database to work. This shield fails during a cache miss. When a user logs in or adds an item to a cart, the system requires unique data, forcing the request to bypass the cache. During a traffic spike, these misses create a bottleneck. Instead of being served instantly, the traffic hits the origin server directly, overwhelming the PHP and database nodes until the site crashes. Caching essentially masks the symptoms of a slow server process, rather than replacing the architecture that causes the delay. Developers solved this by adopting the Jamstack approach, pre-building the entire site as static files to remove the origin server from the delivery path. Historically, this required giving up the WordPress editor and hiring engineering teams to manage complex code deployments. Static edge platforms like Nimbika provide a convergence point. They deliver static architecture while keeping the management experience inside the native WordPress dashboard. When you update a post, the system performs an incremental build. An AI layer maps the relationships between your content and recompiles only the specific pages affected by the change. These optimized HTML files are then pushed out to over 300 global CDN edge nodes. This removes front-end PHP execution entirely. It gives standard WordPress sites the same architecture used by high-end engineering teams without changing the daily publishing workflow. Comparing these three approaches shows a clear performance gap. Standard WordPress averages a score of 45. Caching plugins can raise that to 68. Static edge architecture moves the needle to a near-perfect 99. The time to first byte, the measure of server responsiveness, drops from 1800 milliseconds down to 38 milliseconds. This level of speed is how a website passes Google's Core Web Vitals with perfect scores. On this report, the largest contentful paint is just 0.6 seconds, and the layout shift is 0. The page is fully loaded and stable before the user can react. These metrics determine baseline search engine visibility and whether a visitor stays on the page or bounces in frustration. Since visitors receive pre-rendered static files, your origin server is hidden from public traffic. This creates a layer of security that makes the site immune to traffic crashes and DDoS attacks. Website owners can now use the WordPress editor while serving pages with modern static speed. The long-standing trade-off between ease of use and performance has been eliminated.